Okay, guys. So, as you know, we have already started our uh, 11th physics chapter. So, till now, we have discussed a few of the things, and we are going to move forward. From now onward, if you haven't watched the earlier two video, you can go and find it into the. I have also added a playlist in which you can find that video. In the last video, the voice was not, I think, good. I will record it later, but you can watch it. There is no problem in that. So yeah, we'll start the like we have understood the significant figure. So significant figure is basically uh, what is significant figure? So significant figure like we have already talked about 2.743. There is a four digit which are significant in it because these are non-zero digit. So there are rules we have already talked. We are not going to. Now I want to go with the adding and like multiplying, addition, multiplication and division of these digit, division and subtraction of these digits. So how we can how we come to know that which digit we have to take while suppose we have to add 2.74 with 2.8593. So then here how because this is having only three significant digit but this is having one, two, three, five significant digit. So can we add? Yeah, we can add. But the thing is, which is having the least significant digit, that the second number has to be rounded off till that only. Like this is having three significant digit, then this number would have to be rounded off till it becomes the number that is having three significant digit only. So for that we have to first understand the rounding rounding of significant figure. So how we can round off? So the first thing that you have to get to five. If any number like till any point you want to round off, like till suppose I want to round off till last after decimal last two digit. Here, suppose I want to write is the number which is uh, uh, till which you want to like the last number, and if it is greater than 5, then the number which is precedence of that digit, that should be increased by 1. So like let's start from the last one. Here it is 3. So like we have 2.8593 and it is 3. So if we are saying that we have to round off this number to till 3 digit, so then it should become like here till here only, and let us see whether it is 5 or any other number. So for that I have told you we have to start from the right side, from the rightmost, and we'll see whether it is less than or greater than 5. Now you can see it is less than 5. So the precedence to this, like the next number which is early of this, that have no increment. So that would be remain same and it would be dropped out. So then it means 2.859. It would be like this one. Now now we have reached till 4 digit. Okay. Now we're gonna see whether this number is greater than or 5 or whether greater than 5 or not. So you can see it is greater than 5. So we will increment its precedence by 1. So it will become 2.85 plus 1 6. So 2.86 and this number will be dropped down. So now we have reached our goal because we wanted three significant digits, and now you can see in the in question mark you can write here 6. So the significant the rounding of this number became 2.86. Now you can simply add this number. So you have to find the one number which is having less significant, and you have to round off other number till that significant only. Then you can like do whatever you want. Like if you want to do multiplication, subtraction, addition, then you can do. There is no problem in that. So now you have got. There is some specific rule. Suppose if the number is like if it is greater than 5, if it is if the number is greater than 5, then you have to increment the precedence number by one digit. And if it is less than 5, the number, the last digit here, it number, it means the last digit. If it is less than 5, then you do not have to no increment in the precedence, no increment in the precedence. Now if suppose the last digit is equal to 5, then what you would do? So there is, then we have two rules. The first one, if precedence is even, equal to even. If it is even, then no increment in its precedence. If it is odd, then you have to increase by one, increase by one. Then increase precedence dense by one. So like I'm just gonna give you some examples so that you can easily understand it. What do I mean by that? So like suppose we have 2.84595 3 and 4, and we have 5. So now I am saying that you have to like suppose here I say you have to like you have to get three significant digit in. You have to round off this number till three significant digit only. So you have to start from the rightmost, and you get that this is 5, and the precedence of this is 4. I'm just changing my color. The precedence of this is 4. So 4 is a even number. So what we will do, we will just drop this number, and we will take this number as our next number. So we are taking 2.84953. From here we will start. Now we have this much significant digit. Now we are saying this is already less than 5. So we will again drop it, and there is no increment. So we will keep our chain like say 953. And again it is like less than 5. So we will drop it, and the chain will be start from here 2.8495. Now we see that it is 5 and this number is 9. So it is greater than, it is odd number, and it is 1 also. So what we will do, we will increment this by 1, and we will drop this one. Increment by 1 and drop this one. So 2.8. Now if you increment it, it will become 0, and here it will become 5 0, because 9 plus 1 10. So 10 means 49 50. Now you can see we have reached here, and now it is less than 5. So 2.85 is our ultimate goal, which is still 3 digit only. So you can start from here, but you can skip all these steps. You just see whether where I have to do all these things. So you just directly cut these three numbers, and you see here 5. So you just increment here, and here it will become 5. Now you get to know that this is 0. So yeah, by practice it will be easy. So till now you understood how we have to do. Now I am just taking a simple example for the, actually in this example we have both even and odd out. How? Because here it was even and here it was odd. So we have incremented. So like this way you can do. Now let's talk about the let's talk about You can do addition, subtraction. Suppose I'm doing subtract at multiplications, 7.1 into 1.35. Now if I am multiplying these two numbers, so how many significant digit I will be getting after the decimal? It would be 4, because after we have two decimal here, we have two number after decimal, so then it will become how many digit that will be after decimal, that will be 4. So for that, our result would be in only till three significant digits. So then in that case we have to also do the rounding off. So let's see this example. Suppose we have 7.23 into 1.35. So 5 3 are 15, carry 1, 5 2 are 10, 11, 5 7 are 35, 36. Okay. So now we go to our next number. 3 3 is 9, 3 2 is 6, 3 7 is 21. 1 3 is 3, 1 2 is 2, 1 7 is 7. Okay. Now we add all those. 9 plus 1 10 0, carry 1. 6 6 12, 12 12 plus 3 15, 15 plus 1 16, 6 carry 1, 3 plus 1 4, 4 plus 2 6, 6 and 1 7. 7 plus 2 9. Okay. Okay. So now we have got to know that the digit is like this one. Now, but we know that this is not our accurate result. Now, if you go in some exam, you get some like some you did the calculation or you got this result, and you will click this as the right, but this is not the right one, because the significant digit in this number is still 3 only. So you have to make your digit or your solution still 3 significant digit only, because here it is having 5 significant digits, so it is not correct. So for that you have to round off. Now you can round off from the rightmost side, and you go to the rightmost and you find that it is 5. So and the precedence of this, that is 0, which is an even number. Now you can drop this one and you can also make this continue. So the result will be this one, because this is 0, which is also not greater than 5. So that's why it will be dropped, and we get that 9.6776 is our correct result. So by this way, you can do all the things as well. I'm not going to do all those things because it will take lots of time, which is not like important. You can do all those things. I'm just giving you one example only so that it will clear your concept. Now we'll move on to our next chapter, which is error. I was already discussed in my last video, but it was not like getting voice, so that I am going to again clear some concept here and in brief only. So we have error. Why we have error? Because in any measurement there is not 100% uh, purity. There is no 100% purity in any type of measurement, even if you are measuring it with very minute instrument so in which you are saying that there is no error would be happen, but there is surely that error can come. So the error is ultimately defined under different category, like we have random error. I'm just saying that random error. We have systematic error. Then we have absolute error. Before that, I'm just gonna tell you about. Uh, One second, it's getting clear. It should be okay. So now we have this one. Okay, okay. Um, yeah. So we have personal error. we have partial error, then we have absolute error, then we have fifth one is our relative error, then sixth one is our percentage error. Okay, so we are going to see all these errors in one by one, but these errors are just theoretical error if I'm saying about, and these errors are more bit calculation. You have to do calculation here. And random error is like there is some sort of some happen inside that due to which that error happened. Like suppose somebody has to measure this length and he is not accurately measuring it. He has left some spaces from the end, so there can have some error as well because you cannot get the exact length. So that can be the random systematic error. Suppose the measuring instrument through which you are measuring that type of object, whatever it is, so there can have a error inside of the system as well. So that's why you cannot get the exact result. So that can have in the type of the measuring person can have also some sort of error while measuring, so it can come under the personal error. So these are the theoretical error. Let's talk about the absolute error. So suppose you have measured, there are suppose this length, and how you can basically reduce the chances of error. How you can reduce the chances of error? Like if I would say, how can you improve your chances of success? How can you increase your chances of success? Just by revising again and again. It means by measuring yourself again and again. That I can say. So same way, if there are multiple people who who are measuring this, then they can have a like value like a1, a2, a3, a4. So there are different value. Like if I say n people has measured. Now if I take, and there the variation in these results will be very very minute. Like a1 is almost similar to a2, almost similar to a3, but there is having minute differences. That's why I'm just saying that a1, a2, a3. Now if I take the mean of all these numbers, that would be our, I guess, some exact value, but it is not. It is most exact value. Why? Because we have taken so many experiments. We have taken so many chances of having correct result. So that's why if I would say only three results, then there have chances that somebody has measured 50, somebody has measured 50.5, somebody has measured 50.6. Now you are saying that on the basis of these results only you cannot decide whether what is the correct. So um, so if you have so many results, so many data, then you are taking the mean of all these data, then definitely you can say that this can be the exact or most closer to the exact result. So that's what I am doing here. Suppose we have a just one page. Yeah. Now suppose I have this length, and for that I have measured a1, a2, am. So n number of experiment I have done. If I divide a mean will be equal to mean, that will be our true result. That is equal to a1 plus a2 plus a3 plus am divided by m. That is our mean. Now this is our experimented value. Why? Because we have measured it while doing experiment. It is not that the theoretical value. Now, if suppose someone says that we have the theoretical value or it is the real value, if I say that is having a TI or we can say AR. So now there might have differences, and that is basically that would be differences. So that is called the delta A real minus A measure. That is called the error. Why? Because whatever we have measured, that can have some sort of like some sort of uh, s- differences with its real result, and it would be because you cannot say that this is the exact result. So you have measured there can have some sort of problems in systematic in the system in the like I have already talked about those things. So this error and this is called the absolute error. Absolute error. Now you got to know what is absolute error. Now if I say delta A upon A, that is called the relative error. Delta A is the differences of the real and actual value, and A is the actual value. So that is called the relative error. So if we define relative error, now delta A upon A, that is called the relative error. Okay. Now if we multiply it by 100, then that same error is called as the percentage error. Now, the first thing that you have to find out the absolute error, then you can easily find out the relative error, then you can easily find out the percentage error. Okay, so we are going to take one example to understand uh, the okay. We are going to understand the here. Yeah, now it is. So we are going to the operation on error. Operation on error. You can say like multiplication sub addition of error. Suppose addition of error we have we want to add two errors or subtraction of error we can have multiplication of error, we can have division of error. Now you can say that what we are learning in these chapters, that is related to physics. Yeah, of course it is related to physics. Why? Because whatever you are going to do, that might have an experiment, and there you can have seen some sort of differences. Then how you can define that result is how much accurate it is. So that's why we are understanding the error chapter. So everything is related. You don't have to skip anything. So then we come to know that we have A plus minus delta A. The result is A, the actual result is A, but there is a error that is denoted by delta A. So that means it can be written as A plus minus delta A. Suppose we have another result B plus minus delta B. Okay. So now if we want to, these are the absolute error. Okay. These are two absolute errors. Okay. If I would say add these two errors, what will be the result? Like suppose we have R1 is equal to this one, we have R2 is equal to this one. Now if I say R total is equal to R1 plus R2, so R1 plus R2 A plus B, there is no like any problem in that, you can easily add it. But the problem is here, like plus minus delta A plus minus delta B. So the thing that you have to notice is that while adding errors, we have to, even if it is their negative sign, you have to add their absolute value. Absolute means their positive value. So A plus B plus delta A plus delta B. So the delta R total, that would be equal to delta A plus delta B. I think you got my point. So you have to just add those two absolute errors in the addition. And even if it is subtraction, you even in subtraction you have to add the two results. Like R total is equal to delta A plus delta B. That things you have to do in subtraction. Now let's talk about in 1 second. I just want some page here. Okay. So if I say multiplication of error, multiplication of error. So how can you say, like, suppose we have R1 is equal to A plus minus delta B delta A. And similarly, R2 is equal to B plus minus delta B. Then R equivalent is equal to R1 into R2, which is equal to A plus minus delta A into A B plus minus delta B. Okay, so we have this one, and now we can write it A B, then plus minus A delta B, and similarly we can write it as plus minus B delta A plus minus delta A into delta P. Now you can neglect these two errors. Why? Because they are very negligible, like 0.001 into 0.001. So suppose this type of error, it would be very very negligible. So you can neglect these things. So then R equivalent will be equal to AB. R equivalent is equal to AB plus minus A delta B plus B delta A. So now if I divide R equivalent upon R, so then it will be AB. R is equal to basically AB. AB plus minus A delta B divided by AB plus minus B delta A, B delta A upon AB. So AB will be cancelled out, and here A will be cancelled out. Here B will be cancelled out. Delta A upon A, delta B upon B. So then we have find out that relative error will be equal to delta A upon delta A plus delta B upon B. So R equivalent will be equal to R delta A upon A plus delta B upon B. Here we are taking the maximum error, that's why we have taken the positive sign. Now you can think that why we do not have taken the negative side, because their error is maximum, so that's why we are taking the positive sign only. Okay, so you have to know this. So these are the relative error of A, relative error of B, and if you can multiply it with, then you get the R equivalent. But R equivalent upon R, that is the relative error in the multiplication. So similarly, you can do with the division as well. So now let's take one page another, in which uh, we are going to see division. That would be division, error in division. Okay, error in division. So suppose we have A plus minus delta A upon B plus minus delta B. So how we can see it that uh, that we will like, suppose we have a 1 upon r equal to 1 upon r1 plus 1 upon r. There we have to know the differentiation concept. So if you don't know, I will tell you in later classes. First, let's do some exercise on this one because it is some hectic for you to understand it now. But whatever the concept we have understood till now, like division, addition, subtraction, like addition, subtraction, and multiplication, we can do all the questions, and the majorly questions here will be all these three only, and we will take this one also, but after doing some exercise on this. So let's go to the our NCERT books from where you can do some questions. So I'm just taking, so suppose we have it is not really visible. It's taking a lot of time to get it clear, but don't worry, we are just, yeah, now we have, this is rounding off, then we have, I think from next time onward I will try to make the questions ready already because it is taking a lot of time. Okay, each side of cube is measured with what are the total surface area and volume. Now you can see, I just take my whatever we have discussed, that is here. The surface area of the cube is 6 into its side square, 6a square. So the same thing they have done. Now they have got their result, but they are rounding it off to till the 4 digit only because there is only four significant figures. So now this 4 will be no value because it is less than 5. Now this 5 will have not any like contribution in increasing the number. This is having also not, and this becomes 3 because 9 it's get 10, and this 10 it is become 3, and these two will be rounded off. Now we have this 3, so this is our correct result. Similarly they have done this one, like you can say there is no and this one, this will increase 8, and this will increase 5, and this will become 2, but till here there is no use because it will not going to affect this one because this will, even if it become 2, that is less than 5, which is not going to affect its next digit, which is 7, so it will be same. Now you can do all those exercise. There is no like, there is not going to be hectic for you. Now I'm just wanted to do that exercise related to your, yeah, here it will be, I guess. This NCRT they have like cut down so many things, so that's why it is not good, I think, because if you don't know the basics then you cannot understand how things are working. Like I'm just going, here it is, some example is there, so I'm just trying to get it. Okay, what is this one? Rules for determining uncertainty in the rule of mathematical calculations. Okay, so like we have this length which is having this much, and there's an uncertainty is 0.1 centimeter. Okay, so now we have to find out, oh, percentage. Okay, okay, okay. So how you can do that? That you can just do it by just dividing. I'm just taking my own example. So one example I have, we have two temperature. that T1 is equal to, I'm just 20 degrees centigrade plus minus 0.5 degrees centigrade. So this is the error. Similarly, we have T2, that is plus minus 0.5 degrees centigrade. Now you have to find out the difference of the temperature. Difference of temperature and the error. What you have to do? You have to just T2 minus T1. You have to just this subtract these two, but you have to add these two. So for that, what you have to do is the T2 minus T1, that will become 30 degrees centigrade. Okay, and this will become plus minus 1 degree centigrade. Now you got to know how we can do it. Okay, so if we calculate further, I'm just going. This is the subtraction part. Similarly, addition, you have to just add it, and then there you have to add this one as well. Like if you have to do addition, then you have to just add 70 plus minus 1. This would be the reason. Okay. Now let's move on to the next questions. Uh, that is related to multiplication. So I'm not wasting much time here because it's already, I guess, we have 36 minutes. I would not make it till 45 because it will become so much longer to you. Okay, so I'm just taking some other example. Like suppose we have everybody knows resistance and voltage and I. So we have given V is equal to, that is 100 plus minus 5 volt. Okay, this one, and we have given I, that is 10 plus minus 0.2. 10 plus minus 0.2 ampere. Okay, and we have to find the percentage error in R. V is equal to I into R. So we know that R is equal to V upon I. Okay, so you can calculate it by just doing a multiplication of these two. That would be 10. R would be equal to 10. Now you have to just calculate 5 upon 5 divided by 0.2. That is not going to work out. So what we have to do, we have to get the uh, 5 percentage here, and here it is 0.2 divided by 10 into 100, so it will be 2 percentage. So now it would be added because errors always added. So 10 plus minus 7 percentage. So if 7 percentage of, so this is the 7 percentage error. Okay, so 7 percentage means how much it would be, 10 into 7 divided by 100, so it would be 0 points. Okay, so this is the error which you can get. Now these are the things which you have to do, and I have told you can do so many examples. There is no problem that going to happen. So I guess till here we just take our discussion. Otherwise, it would be very long, and you going to suffer a lot. So that's why I just like take this class till here only. So thank you so much. Keep watching, and please forward this to the viewer who wants to learn something. And we will come with more informative and more structural video with the time because this just my start, so I'm not having so much experience in making video, but I will definitely try to make something which is having wonderful with the physics. You will definitely enjoy learning physics. I'm not going to take into too much uh, like I will make it theoretical as well as the conceptual. The concept is very important. That's why I'm taking these classes. I'm not focusing on the so many questions you might have seen. I'm just focusing on the concept. If you have a good concept, definitely you can do so many questions. There is not going to be a problem. That